so first one, what do you do? In number 3. What do you get? Nope. Condense it. When I condense it, what do I get? Log of 8, well, so log of 5x equals 2. Okay? Oh, forgot to put the marker on. Okay? So now we're sitting here. Now what do we do? Jacob? Switch forms. Okay, what do I do? What do I get when I switch forms? 10 does not equal 5x. 10 squared equals 5x, because my base here is 10, so that becomes 10 squared equals 5x. 10 squared is 100. How am I going to solve for x? So that gives me 20 equals x. What are the 2 rules that when we're dealing with logarithms we have to live by? Argument has to be positive.
Base has to be greater than 1.
No.
Base has to be greater than 2.
But what? Greater than 0. The base has to be greater than 0 but not equal to 1, and the argument has to be positive. So after we get done solving every single problem, we have to make sure that those 2 conditions are met in every single log, in every single equation. Okay? Log base 10 of 5, okay, those 2 conditions are met. 10 is greater than 0, but not equal to 1. 5 is positive. Okay? Log base 10 of 20, okay, condition 1 is met. Base is greater than 0, not equal to 1. And my argument is positive. 2 is 2. Okay? So all of the conditions are met. Then we could type this into the calculator, log base 5, or log of 5 plus log of 20, and when you hit equals, you should get 2. Okay? Over here, what would you do first? What would we do first? Condense it. What does it condense to? Equals 1. Okay. Can I rewrite that at all? As what? Okay, I did something a little different. Can I rewrite this as log base 5 of 15x equals 1? 45 divided by 3 is 15. Okay. Now what? So that's 5 to the first equals 15x. Need to solve for x. Divide both sides by 15. 1/3 equals x. Condition number 1 says that the bases have to be greater than 0 but not equal to 1. And all of my logs are the bases greater than 0 but not equal to 1. Yes, so we're good there. Condition number 2 says all of my arguments must be positive. 45 times 1/3 is... well, for sure it's positive because it's positive times a positive. Okay, so it's really just 15. Okay, so that works out. Okay. So then if I figured out what log base 5 of 15 is, and subtracted off log base 5 of 3, hopefully I would get 1, and actually you do. Okay. Fifth type of problem is where the base is unknown. When the base is unknown, the first thing that you do is you switch forms. Have you seen a common theme through all 5 different problems? What's the common theme that has happened in all 5 of the problems? You switch forms first. Okay? That should be ingrained in your brain by now. Switch forms. Okay? And then because we're solving for the base now, the second thing we're going to do is we are going to take some kind of root or power to both sides. On this particular one, we're taking the 6.7 root to both sides, which it's hard to write an index of 6.7, so we actually write it as a fractional exponent, because just like taking the square root on both sides, that's taking both sides to the 1/2 power, okay, we can put it in as 1 over 6.7, the power there, and then that works out. Okay? So, let's try some. Log base x of 50 equals 3. The first thing that I should do is switch forms. So when I switch forms, this becomes x to the third equals 50. Okay. Now I want to solve for x. So I could cube root both sides, or I could take both sides to the 1/3 power. Those two mean the exact same thing. Okay? Those are the exact same thing. On the left side, I get x. On the right side, I get, reset this, 50 raised to the, I get 3 point, we'll call it 684. Really, I get 3.68403149864. Okay? So, but we'll round to 3 decimal places. Okay? My question to you is this. Condition number 1 says that in my logarithm, I need to have a base that is greater than 0 but not equal to 1. Has that condition been met? What is my base? 3.684. We just found it. Okay? Right? That's good. And my argument has to be positive. 50 is positive. Okay. If I were to type it in, okay, I could use change of base formula, and I could go log of 50 divided by log of 3.684, and I get 3 as an answer. Or I'd get something fairly close to 3, depending on if I round it or not. If I use the rounded or if I used it as the answer, the ANS on my calculator. Okay. Number 2, first thing that we have to do is switch forms. Okay, so the switch formed is to the 1/2 power equals 28. Okay, I want to solve for x. So what? I could not square root both sides. I'd square both sides. Left side then would give me x. Right side would give me 784. Condition number 1 says my base needs to be greater than 0, but not equal to 1. Have I met that condition? Yep. And 28 is positive. So I met condition number 2 also. Okay? What I'd like you to do now is I would like you to do numbers 3 and 4. First thing I'm going to do in number 3 is switch forms. So that gives me x minus 2 raised to the 4.1 power equals 23. Okay? Then I'm going to take both sides to the 1 over 4.1 power. Okay? Now, don't use the fraction button on your calculator because it's not going to work because you've got a decimal. Okay? Fractions aren't supposed to have decimals in it, so your calculator doesn't like it. And it would say syntax error. And the last 2 classes have been like, oh, it doesn't work. How are we supposed to do it? And I just switched the fraction symbol to a divide symbol, and it worked just fine. Okay? So my right side, or my left side here, gives me x minus 2. My right side gives me 23 raised to the 1 over 4.1 power gives me 2.14, we'll call it 846726265. Okay? Add 2 to both sides tells me x equals 4.148. Condition number 1 says that my base has to be greater than 0. Is my base greater than 0? Is it equal to 1? No, so that condition is met. Condition number 2 says 23 has to be positive. Works out. Okay? So when I check it on my calculator, the log base 2.148, after I subtract 2 from the original one, of 23 gets me that answer. Okay? Second one, switch forms. Gives me 3 minus x to the 2.8 power equals 88. I'm going to take both sides here to the 1 over 2.8 power. That gives me 3 minus x here equals, what's 88 to the 1 over 2.8 power. I get 4.94832364883. Now what? No. Subtract 3 gives me negative x equals 1.948. So what's x equal to? Negative of that, right? Ruh-roh. condition number 1, Megan, says that my base has to be positive but not equal, or greater than 0 but not equal to 1. Do I have that condition met? Huh? Condition number 1 says that my base needs to be greater than 0 but not equal to 1. Is condition number 1 met? You sure? What is my actual base and when I put it back into the problem? 4.948, right? Okay, so is condition 1 met? Yes, condition 1 is actually met. Okay? 3 minus a negative is like 3 plus. Okay? Your base is actually right there. That's what your base is. Because that's 3 minus x. Okay? So it actually is met. So just because you see a negative sign doesn't mean it automatically gets kicked out. Okay? You've got to put it back into the problem in order to check it. Okay? And it's got to be checked all the way through. Okay? So, skip this page and go to the extraneous solutions page. And I'd like you to do number 2. We'll start with number 2. First off, what would you do? Condense. Okay. If I condense, I get log base 5 of x squared divided by 4 equals 2. Okay. Now that I have it down to a single log, now what? Switch it. So that would become 5 squared equals x squared divided by 4. Five squared is? Solve me for x. Okay. What do you get? Okay. What do you get? What do you get? What do you get? The one thing we told you not to forget for the entire year. We told you way back in September, and it came up. This is both probably the 15th or 16th time that it's come up this year. Got to remember that anytime you take an even root and you're solving, it's different if you're simplifying. If we were just simplifying the square root of 100, it would be 10. But we're not. We're solving here. So anytime that we're solving, we have to add the plus or minus. Now, my question to you is actually even before I before I put the box around it, I should ask the question, do both of them work? What are our two conditions? Okay. So what? So why not? Which one doesn't work then? What's wrong with negative 10? What do you mean it's not positive? But what's negative 10 squared? You know what I mean? Okay? So, on the surface, both conditions are met, right? Okay? So, what is log base 5 of 100 minus log base 5 of 4? Is it 2? Because it would be 100 divided by 4, right? So really it's log base 5 of 25. What exponent do I put on 5 to get me 25? 2. So they both work out. Okay. Next one I'd like you to do is number 3. Spot check, condensing, should look like that. Changing forms should look like that. Doing the math should look like that. But now we're at a crossroads. Now what do we do? Nope. If I factor, I'm going to go right back up to the green step. Subtract 27 and get it equal to 0 first. Now what? Now we factor. Okay, what is the right side factor to be?
It's going to be 5, or it's going to be x minus 7, x plus 5.
Two numbers that multiply together to be negative 35 and add to be negative 2, or negative 7 and positive 5. Now what? So x minus 7 equals 0. So then x equals positive 7. X plus 5 equals 0. So then x equals negative 5. Okay. So what now? So we plug them back in. So if I put in 7, log base 3 of 7 minus 4. 7 minus 4 is 3, right? So log base 3 of 3 is log base 3 of 3. Shouldn't need a calculator for that one. One of our properties. It's 1. Okay, what exponent do I put on 3 to get 3? That's 1. Okay. If I put in 7 into the other one, I get plus log base 3 of 9. What's log base 3 of 9? 2. Okay. What's 1 plus 2? Is 3 equal to 3? Yeah, so that one checks out. Okay. Next check. log base 3 of negative 5 minus 4. That's negative 9, right? What is log base 3 of negative 9? What? Why is it nothing? Because the argument has to be positive and my argument's negative, right? So what happens to negative 5? It's gone. So my only answer here is 7. Again, I highly stress, just because the negative 5 was negative is not the reason that it got kicked out. Okay? It did not get kicked out based solely on the fact that that answer was negative. You have to put it back in and do the math. Okay? Because you will sometimes, there are some problems where the negative one works and the positive one gets kicked out. Okay? Okay? There are some of those problems in your homework tonight where the negative works and the positive one gets kicked out. Okay? You have to do the math. Okay?